vectors. You guessed it, there's more. So what we're going to do is we've talked about how to solve a vector with angles, but let's go back and let's look at vectors that actually lie in a straight line. Now to do that, we're going to talk about the weary hiker and the mutant teddy bear. The weary hiker is trying to elude the mutant teddy bear, so he uses a hand glider to jump off a cliff. His initial velocity is 15 meters per second when he encounters a tailwind of 3 meters per second. What we want to know is what is his resultant velocity. These problems that I'm working will not help you at all if all you're going to do is watch the podcast. You have to get your calculator out, you have to get paper out. You've got to do these with me or they're not going to help you at all. Use the pause button and get those things ready. And let's work this problem. Now remember we said that a picture is worth 1,000 words. It is still worth 8,000 words. So get your straight edge and we're going to draw that picture. Now our information from the problem is that the weary hiker, it has an initial velocity of 15 meters per second. And then he encounters what's called a tailwind. So let's start with the 15 meters per second. So I'm just going to draw a line. And that's going to represent my 15 meters per second. Now this particular problem did not say north, south, east, west, and I did that on purpose because there's yet another way, and we've talked about it already, but another way to describe direction in physics, and that's with positives and negatives. So in this particular case, we're just going to use positives and negatives. Since there's not a negative sign in front of the 15 meters per second, then that's a positive value. He's going in the positive direction. Now, it also says that he encounters a tailwind of 3 meters per second. Now, a tailwind is a wind that kind of pushes you from behind. It's a wind that's going to help you out. There's two ways you could draw it. You could draw it to the front. Now, we talked about also about drawing our vectors head to tail. We still have to draw them head to tail. So I could put my tailwind here and make it 3 meters per second. Or I could have drawn it, if this was my original 15 meters per second, I could have drawn it in the back there to represent the actual tailwind. Both of these representations would be correct. The thing to remember is that they are still drawn head to tail. There's no angle between these, so that makes these types of problems very easy to solve. All you have to do is add the 15 and the 3, and your resultant would be 18 meters per second. Now you could put a positive sign in front of that, or you could leave it because by omission you are saying that this is a positive value. So his resultant velocity is 18 meters per second in the positive direction. But now let's say that a different set of circumstances occurs, but in this case the weary hiker is going to experience a headwind of 20 meters per second. So let's write that problem out. Okay, so we have the winds shift, and now the weary hiker experiences a headwind of 20 meters per second. Back at the cliff, the mutant teddy bear is watching. What is the resultant velocity, though, of the weary hiker if we now have the headwind? Well, if a tailwind kind of pushes you, then a headwind is going to oppose you. So if we draw this one out, he had 15 meters per second was his velocity. But now he encounters a headwind of 20 meters per second. Now we need to still draw these head to tail. So if this is the head of my 15 meters per second, then I've got to draw them head to tail. So I start at the head of this one with the tail of the other, and we go in the opposite direction. So now what we see is that these two things are going, or these two vectors are going in opposite directions. In order to do that, we now have a positive 15 meters per second plus a negative 20 meters per second. So when we add these two, we find out that the mutant teddy bear is going to get very excited because now all of a sudden our weary hiker has a velocity of a negative 5 meters per second, which means he's being pushed back toward the cliff. Okay, again, we're showing our directions with positives and negatives. Let's say that the mutant teddy bear doesn't quite get his wish, and instead the weary hiker manages to get to safety somewhere on the ground. Now where he lands is not quite at his cabin. If he can get to his cabin, he knows he'll be safe. So let's look at where he does land, and let's work out a problem where he'll get back to the cabin at the shortest route possible. So we have the Weary Hiker's cabin, which is 35 meters south and 57 meters east of where he has landed his hand glider. The Weary Hiker hears a noise and fears the mutant teddy bear has found him. What is the most direct route the Weary Hiker can take to return to the safety of his cabin? Okay, so this is going to be a vector problem with a triangle in it. First things first, always draw this. Draw them head to tail. I'm going to draw my longest one first, and it's going to be 57 meters to the east. Now remember, there's lots of different ways to draw these. I also know it's 35 meters south. The one rule you need to remember is to draw them head to tail. And again, there's my head and tail. So 35 meters. My resultant is drawn from the tail of the first to the head of the last, and with a dashed line. Now don't forget, guys, those arrows are muy importante. Do not leave off the arrows. That's what I'm looking for. I'm looking for the length of that side, and I'm also looking for that angle. Remember, when we have an unknown angle in physics, we just name it theta. You can call it angle Bob if you want, but I'm just going to call it theta. Okay, first things first is to find the hypotenuse. To do that, we use Pythagorean theorem, which is a squared plus b squared equals c squared. So if we take the square root of a squared and b squared, we'll get c. So 35 squared plus 57 squared, take the square root of that, we'll get our value for c. Come over here to the calculator. I do second function x squared, because that gives me my square root. 35 x squared plus 57 x squared. Hit enter, and that means c has a value of 66.9 or 67 meters with the correct number of significant digits. So he's going to have to run 67 meters. Now we need to find out at what angle or what direction does he need to run the 67 meters. You can use any of the trig identities, especially since you know all three sides. Again, I'm going to use tangent, and the reason again that I use tangent is because the 35 and the 57 are given to me in the problem, and should I for some reason have miscalculated my hypotenuse, I would be using an incorrect value in solving if I used sine or cosine. So this is just one way to reduce error. So I'm going to use tangent, and I'm going to say the tangent of theta is equal to the opposite divided by the adjacent. So that gives me 57 divided by 35. Now to actually find that value, theta is going to equal to tangent to the -1 of 57 divided by 35. So I have to do second tan on my calculator, and then 57, divide that by 35, close off my parentheses, hit enter. And you see I have a very low value. I have a value of 1.02. That's a clue that, hey, maybe I'm in the wrong mode. So I'm going to check my mode, and sure enough, I'm in radians, so I need to change that over and hit degree, hit enter, and then second quit, and hit enter again, and that gives me a value of 58.4, or if I'm using the correct number of significant digits, 58 degrees. Okay. Last step is to use that compass rose trick that we talked about, and I'm going to put it in right where I started, okay, where the two tails meet. My solid line is the south line, and to reach my dashed line, or my resultant, from the solid line, I have to move to the east. So I have to go east off of south, so it's east of south. So my whole answer, if the Weary Hiker wants to avoid the mutant teddy bear, he needs to go 67 meters, 58 degrees east of south. I hope that helps. The more practice you do, the better you are at this, and the more comfortable you will be with working with vectors. Vectors are very, very important in physics. You need to make sure that you do understand how to do these.